Okay, 6th grade math 2.6 in the book. It is page 88. So let's take a look at a couple of vocabulary words on page 88. Some of these it's best if I draw pictures to show you what I mean. So I'm going to start by drawing you a picture of a coordinate grid, and that's made up of what's called an x-axis and a y-axis. The x-axis always goes left and right. The y-axis always goes up and down. So this is the y-axis, this is the x-axis, and that's the axes, plural. Axes is plural for axis. Coordinates is like if you plot a point, you go over and up and there's a dot right here. That coordinate, it might be coordinate 2, 2. Coordinate is the location of a point. Okay, the ordered pair is how you name it. It's how you, let me see what the book says for an ordered pair. It's described, it's numbers that describe the location. Okay, the origin is right here at 0, 0. Okay, the origin is 0, 0. Okay, and a line graph is just a visual representation. Instead of a bar graph, it's a graph like this. A graph, instead of bars, that uses lines. Okay, so let's go through and look at some coordinates and some different things. It says graph the point 4, 3 on a coordinate grid. So you always start at the origin, which is 0, 0, which is right here at this point. And 4, 3, the first number tells you how far you move over on the x-axis. So we go over 4 and up 3. And you put a dot. There's 4, 3. 0, 2, same deal. You start at 0, 0. The first number tells you how far to move to the right. So 0 says you don't move at all. And 2 says you go up. So it's right there, 2 places. And there's 0, 2. That's it. Example 1. All right, let's talk about... well, it looks like we skipped, so maybe the guided practice will come back. Let me see if I don't see the guided practice. But the guided practice, if it doesn't show up here in a little bit, you guys get the graph paper that I handed out, and if you haven't gotten any, make sure you get some from me, that graph paper that has the coordinate grids on it, and you can graph those points. There's 1, 2, 3, and 4 guided practice problems, and you guys can graph those. You guys can do those on your own. You've probably graphed things on a coordinate grid for a long time. Making a line graph. The table shows the population of Austin County in southwest Texas from 1920 to 1990. Make a line graph of the data. So here we have, usually this part right here is what I use for the title. Okay, the year goes on the x-axis. The population goes on the y-axis. So they made points for each one of them. You don't really have to do that. Notice they labeled the x-axis the years. Each one of these, 1920, 1920, 30, 40, 50, 60, 70, 80, 90. And then notice they have this little, I call it a little lightning bolt. That's a broken scale. The data doesn't start until a pretty high number. So you don't have to go 1,000, 2,000, 3, or 2,000, 4,000, 5,000 if there's no numbers there. So you can start at a more appropriate number. So notice they didn't start the graph until 12,000, but then after that they numbered by 2,000. So that's called a broken line graph. And then they just plotted each point. 1920 had so many people, 1930 had so many people, and they connected the dots. Okay, so guided practice, use the graph above. In which year was Austin County population the greatest? So if we go back, the greatest means which one has the highest point, and right there, so 1990 was the greatest. And over which decades did the population have the greatest increase? How can you tell from the graph? So if we go back to the graph, the greatest increase would be, where is the line the steepest between 2 points? It's got to go up. Here, notice it stayed the same. Here it went down, went down, went down, stayed the same. Here it went up, and here between these two went up. But how do we know which one went up the farthest or the fastest? It's the line that's the steepest. So between 1970 and 1980, that's when the growth was the best. It went the fastest. And how can we tell that on the graph? Because it is the steepest line. Okay, example number 3, comparing graphs. So we go in and we look at comparing these graphs right here. We have radio stations. The two graphs below show the number of AM radio stations in the United States. The first uses a full scale. The second uses a broken scale, deleting the values 0 to 4,500. Compare the graphs. So you'll see that right here, because the scale is so wide on this one, it really doesn't show much difference between the numbers right here. They almost look like they're in a straight line. But if you take and break the scale down, this one, look, it's by hundreds, you can really see that over the years the radio stations did go down quite a bit. Over here it looks like, yeah, they went down, but it doesn't really show it very much. So that's why you don't want to use really wide, really big numbers depending on the data that you are graphing. So they're accurate displays. They have the actual numbers, but because of the scale, the one on the left shows a very slow decline when the one on the right looks like it's way worse. But it's really the same amount of numbers. Well, I'm noticing that I don't have a lot of the guided practice, so please go through and do the graphs for me on the guided practice on your own, and use graph paper, cut and paste it on there, and then make sure you use graph paper on your assignment, and then I'll see you on the next assignment.